Hi, 11.3 continued question 5. Which of these units are correct for the surface area of a solid? The key word is area. Now you know areas have two dimensions, and you usually work out an area by multiplying a length by another length, essentially. So if you multiply, say, 5 centimeters times 2 centimeters on a rectangle, you go 5 times 2, 10 centimeter squares. So we're looking for a little square, aren't we? Millimeters square? Yes. Centimeters cube? No, because that's a volume. Power of 3. Meters squared? Yes, that's an area. Millimeters? No, that's just a single one-dimensional length. So that's a length. Kilometers squared? Like a large area of land? Yes, that's an area. And centimeters squared? Yes. So these four have a power of 2 and therefore represent the units of an area of some sort. By the way, it talks about area of a solid. Well, land is pretty solid, and you tend to measure it, the area, in terms of kilometers squared or miles squared or something. That's that done then. Right, question 6, lovely. Calculate the area of the curved surface of each of these. Well, I didn't do part C because it's just too much. Now look, curved surface, it wants the area of this part unravelled. In other words, not the bottom, not the top. If I was to take off the top and the bottom and throw it away, I'd get a hole through it, wouldn't I? Put my hand through it and wiggle. If I unravel this curved surface, it is in fact a rectangle. Alright? And this rectangle will be 14 centimeters high. Got it? Now, question. What was this straight line before I wrapped it up? Answer, it was a straight line. But when I did wrap it up, what did it become? It became the circumference of that circle there, and therefore the circumference part of that cylinder. And also it became, the bottom part became the circumference of the bottom part of that cylinder. Therefore, the circumference of a circle is 2 pi times radius. Is that alright? So 2 pi r would be the circumference of that straight line, and when I wrap it up, it becomes the circumference of that circle. Therefore, how do I work out the curved surface? I unwrap it. I can see my radius is 6 centimeters. So now I'm going to treat it like a rectangle and get on with it. I've got here 2 times 3.14, there's my pi, times 6, and then I've got to multiply it by a height of 14. So here I go. Curved surface area is going to be 2 times 3.14 times 6, so it'll be that times 14. That's an area of a rectangle, which becomes my curved surface. So here I go. 2 times 3.14 times 6 times my vertical height of 14, all comes to 527.52 centimeters squared. Is that alright? Great, isn't it? So, don't go learning the formula 2 pi rh. Don't do that. Work it out from first principles. This is a circumference when I wrap it round. I've got the radius, so 2 times pi times 6 multiplied by the height, which is the height of the rectangle, which became all curved, and that's what I do. That's it. Same with this one. I know it's lying down, so let's just put it round the right way, shall we? So what have I got? I've got one of these. I've got radius of 8.4, so if I put r equals 8.4, and this lazy little rectangle that's lying down has got a height of 32, and these are both in meters. Alright, so I've got all I need. So let's just convert it into a rectangle so we can see it. The height is 32 meters. Okay, I've unwrapped it now, and the length will be 2 times pi times radius. In other words, 2 times 3.14 times the radius of 8.4. And here we go. Curved surface area equals 2 times the pi times the radius 8.4 times the 32, which is the height of the rectangle, here I go. 2 times 3.14 times the radius of 8.4 multiplied by the height of 32 meters. This is going to be big. Yep, I thought so. 1,688.06 meters squared. That is a large surface area to make a cylinder that size. It's huge. Anyway, that's the calculation for that. Let's see if I can get this on the same video without getting too long. Question 8. Here are two closed cylinders. In other words, they have a top and a bottom. Alright, so they got a 6 and a radius of 6 there, and they got a bottom part as well. That's also got a radius of 6. It's got a height of 15. Now, let's deal with this one first. The total surface area. I've got a circular top and a circular bottom. Let's do that first. So I've got circular faces have an area of bit scrunched up there, never mind. Here's what they got of pi times radius squared, pi r squared, which is 3.14 times 6 squared. Got that? Let's just do that now. So 3.14 times 36 basically. So the top and the bottom have a radius, have an area of 113.04, and it's centimeters squares. And I've got two of these now. So 2 times 113.04 takes care of the top and the bottom. So times that by 2 gives me 226.08 centimeters square. Now let's do the curved surface. Remember the rectangle? It goes 2 pi r, then we multiply that by the height of 15. So here we go. 2 times 3.14 times, it's the radius of 6, times the height of 15. And here we go. 2 times 3.14 times the radius of 6 times the height of 15 centimeters. That gives me 565 gotten glitchy again, 0.2 centimeters squares. So curved surfaces, those two, the areas of the circles, the circular faces rather. Now I'm going to go for the total surface area. It's going to be 226.08 top and bottom, plus the 565.2, that's the curved surface. Let's get the total answer there. Plus 226.08. That gives us a grand total of 791.28 centimeters squares of surface for that. Now the calculation is identical for part B, and let's do that as well. But please be careful, the radius is not 6, the radius is 3. We've been given a diameter there, so let's just remind you of the word diameter. Diameter is 6, therefore the radius must be 3, because it's half of the diameter. There you go, 3 there. So, same procedure with this one. I won't use the words again, just jump straight in. Let's just do the circular faces. So, area equals pi r squared, which means 3.14 times 3 squared, which gives me 3.14 times 9, 28.26, and it's meters squares this time. I've got two of them, so 2 times 28.26 is going to be, so that takes care of the top and the bottom, 56.52 meters squares. Now the curved surface, I've got 2 pi rh, which is going to be 2 times 3.14 times the radius of 3, not 6, multiply the height. Well, it's lying down, but never mind, it's actually 12 meters tall, makes no difference. So let's just do that. 2 times 3.14 times 3 times a height of 12. That gives us 226.08 centimeters, sorry, not centimeters, honestly, meters squared. Just check that. 2 times 3.14 times 3 times 12. So 36 times 6. Yeah, it's quite big, isn't it? Just doing a random check on that. Yeah, it's huge. Right, so what have I got? I have got... Yellow's useless. What am I even doing with yellow? I essentially have those two, top and bottom, for the circular faces, including that one. And I've got the curved part. So total surface area is going to be 56.52 plus 226.08, and that's going to give us 56.52 plus 226.08, altogether 282.6, and that will be meters squared. And that's question 8 done. It's a lovely question. Do remember to use the formulae. Go back to first principles. Remember, circumference is 2 pi r. Remember, the surface area is pi r squared. Remember, the curved surface along the curved part is 2 pi r times the height, because the rectangular straight edge does form the circumference of the circle when you wrap it round. And so that's it for question 8, and that is the end of 11.3. So thank you for listening. Your turn to learn.